All right, today we are working on lesson 1-3. Again, put your date. I gave you October the 21st. Take that for whatever you like it for. We're going to do our vocabulary a little bit different tonight. There are so many words, I didn't want to bog you down writing definitions. I think examples will be more effective. Our first 3 vocabulary words are radical symbol, otherwise known as the square root sign. This is the radical symbol. The radicand is the number under the symbol. The whole thing together makes up what we call a radical. Now, if we were to simplify this radical, what would we end up with? I know you all just said 5. Go ahead and put this in your notebooks just like that. You might have written it down while I did it. If not, pause and then come back to us. The next set of vocabulary words I have to show you, there's a concept that we have to get through first. So here we go. I would like you to think about a group. Like this group. Let me zoom us out a little bit. The UFS community, and think about all of the people that are involved in that community. Some of them I have listed over here. Parents, alums, trustees, the part-time teachers, younger or older siblings, friends, all the people that are in any way connected with the community. Now, there are actually a few that I left off. Those, let's check out this group of people who are part of the community. This says, people whose job it is to be at UFS every day. Who's in that group? Well, Nancy, Bob, Jackie, our office manager. They're part of the community. But they're at school every day, but we still don't really have everybody, do we? Let's look at this group. People whose job it is to be in the classroom. Yeah, we got a few examples of that. Daphne, Colleen, Margaret. But we're still missing a group, aren't we? Check out this group. We've got students, too. And I just gave a few names from various grades. Now, take a look at what I did. All of the students are part of the UFS community. All the people whose job it is to be in the classroom, part of the community. All the people whose job it is to be at UFS every day, part of the community. As you look at this, each of the smaller groups are also a part of the whole, right? I could just put the students here. I could just put people whose job it is to be in the classroom right here. Yeah. I could put the students are a group who have to be at UFS every day. I could put them in that group. These smaller groups are called subsets of the whole set. All right? The whole set, UFS community. This whole set, as I have drawn it here, has 1, 2, 3 subsets. Okay? Each thing that I listed is an element of the set. So, Layla is an element of the set UFS community. She's an element of the set subset students. Parents are an element of the set UFS community. All right. Now, what about things that don't fit at all? Try this. Agents of S.H.I.E.L.D. Tony Stark. Thor. Captain America. I only found a small picture of poor Captain America. None of these people have any connection with our set UFS community. These two sets do not relate. They are different. If we wanted to make a bigger set, they're all people. I could say we're all characters, but, okay, none of these people have any connection to UFS. If Nick Fury comes to recruit any of you, I will redo my diagram. But until that point in time, we've got 2 sets. Now, the reason I went through all of this, because the next 3 vocabulary words that I want you to put in your book are set, set element, and subset. Take a couple minutes, think about some other example like I gave for UFS community. Okay, could be a set of, I don't know, musical instruments, or something scientific, or the stuff in your room as opposed to the stuff in your house. But take a couple minutes, give me an example of something that fits there. Okay, I'll wait. Now that you've finished that, all right, the last vocabulary words for today. You're going to give me some examples. Natural numbers, these are the nice ones. These are the ones that you think of when you just think of basic, easy numbers. 2, 5, something like 9/3 fits in this set. Why? Because 9/3 is equal to 3. Something like the square root of 16 fits in this set. Why? Well, because when you simplify it, it's 4. Okay? Natural numbers. Now, the set of whole numbers is natural numbers and 0. Okay? The only difference between the set of natural numbers and the set of whole numbers is the inclusion of 0. Our next set is called integers. Integers are positive or negative, includes 0. Okay? You see how we're growing our set? We start with the smallest group of numbers, then we've added. Well, what comes after integers? We're getting into rational numbers. Rational numbers are lots of different kinds of things. They could be fractions that don't reduce to a whole number, like 2/3. They could be decimals that repeat, like 0.3333. They could be decimals that have a pattern, like -.251251251. So, if those are rational numbers, I know you're all dying to find out what irrational numbers are. Irrational numbers, this is where numbers like pi belong, because we don't know, there's no repeat, there's no pattern on pi. Something like the square root of 10. Take a minute and try to find that on your calculator. Or the opposite of the square root of 123. These are all irrational numbers. Okay? All of these numbers, all of these sets together make up real numbers. So real numbers are all of the above. Okay. In your book, on the bottom of page 18, they've given you a picture to show this. They start with the subset of natural numbers, which is part of the subset of whole numbers, which is part of the subset of integers, which is part of the subset of rational numbers. Irrational numbers are over here like the agents of S.H.I.E.L.D. They're not part of rational numbers. Real numbers includes everything. This is important. You're going to have to know these vocabulary words and be able to use them properly. When I ask you for examples of these, I'm going to want you to understand that while 7 is a natural number and a whole number and an integer and a rational number, I want you to know, where does -2 fit in this? Where does pi fit in this? You've got to know the differences, what puts things in one category instead of another. Okay? Now, it's time to back up and do a few problems. We started with the vocabulary and now we're going back to catch up. I want you to take a look at simplifying square root expressions on page 17. Simplified form of each expression. Here's an easy one. Square root of 81 equals 9. 9 squared equals 81, right? Ooh, B is fun. It looks scary, the square root of 9/16, but you can take the square root of 9, you can take the square root of 16, so that's equal to 3/4. And actually, let me slow down and show that one to you in real time. Let me label this properly and put it on film. Problem 1. The example they give you is the square root of 9 over the square root of 16. The thing that they didn't put in your book, and I wish they had, that is equal to this. See what I did there? Once you've done that, it's much more obvious that that's equal to 3/4. Okay? I would like you to do got it, which is number 1 with 4 parts. Okay, you take time and do that. I'll wait. So, next, problem 2. Ooh, we've got a fun thing with lobster eyes and stuff like that. They're showing you how to estimate square roots. Notice they don't want an exact square root. They want an estimate. Find the 2 closest perfect squares. Ooh, helpful. The perfect squares closest to 386 are 361 and 400. How do we know that? 19 squared is 361, 20 squared is 400. So, 386 is closer to 400. Square root of 386 is approximately 20. They use that wavy equal sign. And that's all we need to know. Method 2, estimate that using a calculator. Now, to me, if you're estimating, you're not using a calculator. Those are a little mutually exclusive, because that's finding it exactly and chopping off the decimal. So if they say estimate, I don't want you using your calculator. All right, next, got it, number 2. What's the value of the square root of 34 to the nearest integer? Use method 1. Got it. Number 2. Okay. Next, they go through the sets of different numbers, which we went over as part of our vocabulary. Rational number, natural numbers, and here they're showing you what it looks like if you graph them on a number line. Whole numbers, you add the 0. Integers, you add the negatives. Irrational number, you can't Here's the fancy definition. You can't represent it as the quotient of two integers. In more helpful terms, irrational numbers do not terminate or repeat, which means they don't end. For example, this one, which has no pattern, it's just ones and zeros, or pi, which we've already talked about. The reason they have this group of definitions right now is because we're working with square roots, and some of them are rational, some of them are irrational. If they work out nicely, they're rational. If they're ugly, they're irrational. All right? Both of these are sets of real numbers. So let's review this a little bit. Classifying real numbers. To which subset does each number belong? And look, they give you a list. For 15, it doesn't just say natural numbers. It's also a set. It's also in the subset of whole numbers, integers, and rational numbers. For this one, negative 1.4583, it's only a subset of rational numbers because this ends. If it didn't end, then it would be an irrational number. Square root of 57 is an irrational number because it's not a perfect square. So go ahead and do got it, number 3, all 3 parts, and I want to know all of the subsets that any of these belong to. Okay? I'll wait. All right, we've got just a couple things to finish up. I'm looking at the top of page 19 where they give you some review. An inequality is a mathematical sentence that compares the value of two expressions using an inequality symbol. You know these symbols, less than, greater than, less than or equal to, greater than or equal to. Something that's a little bit new is problem 4, comparing real numbers. What is an inequality that compares square root of 17 and 4 1/3? Well, first you have to make them into the same format so you have some chance of comparing them. So you're going to estimate the square root of 17, or use your calculator. Square root of 17 is that irrational or rational? I'll ask you that in class. And then you turn 4 1/3 also into a number with a decimal, and then you can figure out which one's bigger. You compare them. I'd like you right now to do the got it question number 4. What's an inequality that compares those two numbers? And is there another inequality you can write that compares the two numbers? Just think about that. It's a useful question, not obvious at first. You go ahead, stop the video. You know I'm waiting. Okay, last but not least, we are doing a little bit of graphing and ordering the numbers using a number line. Oh, I dislike multiple choice a whole lot. I suppose it makes sense right here. They give you 4 numbers. What's the correct order? Well, you look through those and you take your pick. Like we did up above, you need to put them all in the same format so you can compare them. We've got one in the form of a rational number with a decimal, number, decimal. This one, same format. We need to put this into a format that we can compare it to, and the square root of 4. So, you compare them, figure them out, goes through the steps, and it shows you what they mean by a graph. This is just a number line. They've put everything on the number line. Does not have to be exact, but it has to be close. Notice how they've put these nice integers down below so that you can keep your place, and then you guess. Square root of 4 is exactly 2. That dot goes right there. That's a little hard to see. There we go. Square root of 2 is in between 1 and 2, so put it there. 0.4, just under halfway, and so on. Now, you get to do the same thing. Problem 5, graph 3.5, negative 2.1, square root of 9, negative 7 halves, and root 5 on a number line. After you finish that, go on to the next page. Do the lesson check. all 8 problems. It's only 8 problems. And we'll check them tomorrow in class. Good job. We're done.